Welcome to Study Loop.
Okay. Um, so we're rolling a die until we get a number larger than 4, which in this case means rolling a 5 or a 6, right? So we can kind of simplify this. We don't really have to think about rolling a die or anything like that. Recall that rolling a 5 or a 6 on a 6-sided fair die is just something that happens 1/3 of the time. That's all we really need to know, is that every time we roll the die, we have a 1/3 chance of hitting a 5 or a 6. Okay. So a success is just has a 1/3 chance, and a failure, right, has a 2/3 chance, right? So if we look at this from like a conditional probability thing, we say, okay, success, that's 1/3, failure, that's 2/3. Okay. So what are the odds then that we get it right the first time? Was 1/3, right? That is for k to equal 1, right? The probability um, when k equals 1 is just 1/3. That's the odd of uh, getting. It's the odds of rolling the dice only once and succeeding. Well, let's assume that I have to roll the dice twice. That like what happens then if I fail, right? Well, I would continue on. And once again, I'm either going to fail or succeed, right? So if I succeed, that still has a 1/3 chance of happening, right? And for me to fail again, still has a 2/3 chance of happening. But now, what are the odds, right, that I would succeed having rolled the dice twice? Well, it's going to be 2/3 times 1/3, right? 2/3 that I failed the first time, and then 1/3 that I succeeded, right? That's the odds of going failure then success, right? And I stop once I succeed. So that's all I need to consider. Okay. So for k equal to 1, it's 1/3. For k equal to 2, right? It's going to be 2/3 times 1/3. Okay. And what if we keep going? Okay. Well, if we succeed, that always has a 1/3 chance of happening. And if we fail, that always has a 2/3 chance of happening. Okay, so what does the probability look like uh, to have gotten fail, fail, success? Well, that's 2/3 times 2/3 times 1/3, right? For k equals 3. And we may start to notice a pattern. We can continue this, right? To succeed would be 1/3. Right, so to fail, 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 succeed, the odds are 2/3 times 2/3 times 2/3 times 1/3. And we see that every time we're basically just adding a multiple of 2/3, right? For k equals 4. So this is basically, we just need to convert this into a formula that will tell us p of n equaling k for k equals 1, 2, 3, et cetera, et cetera, et cetera. Okay, so this is our P of n. Okay, and so we'll see that basically we're just going to get P of n equals k for k equals 1, 2, 3, et cetera, et cetera, et cetera, is going to be k minus 1, or sorry, 2/3 to the k minus 1, right, times 1/3. Does this seem right? Okay, when k is 1, right, then we'll get 2/3 raised to the 1 minus 1 times 1/3, or 1 times 1/3, or 1/3. Great. When k is 2, p of n equals 2. Okay, we're going to get 2/3 times 2 minus 1 times 1/3, or 2/3 to the first power times 1/3, or 2/3 times 1/3, which is exactly what we wanted to get, right? Or we could simplify it further and say 2/9. The point is that it's getting the correct answers. And each time we'll just get another multiple of 2/3 out front, right? So 2/3 to k minus 1 times 1/3.